Hello students, welcome to part 2 of section 5.5. We're going to continue here with the power reducing formulas. The power reducing formulas are interesting because we're able to take sine squared, cosine squared, and tangent squared, and yet again write them as something else. For sine squared, it's 1 minus cosine 2u all over 2. For cosine squared, 1 plus cosine 2u all over 2. And then for tangent squared, 1 minus cosine 2u all over 1 plus cosine 2u, which you can actually derive just by doing sine squared divided by cosine squared. Example 4. So what we're going to do is rewrite cosine to the fourth as a sum of first powers of the cosine. This will also, in some instances, be referred to as reduced first powers. Okay, so I'll note that. And as we look at the function itself, cosine to the fourth, like we saw in a previous example when it was, I believe, sine to the fourth, we reflect upon that here on the previous page. When we rewrote sine to the fourth as sine squared squared, we're going to use similar logic in simplifying cosine to the fourth. Okay, so when we take a look at cosine to the fourth, right away we'll say cosine squared squared, which in turn, if we take a look at the second formula here, cosine squared being 1 plus cosine 2 times the angle all over 2, and that whole quantity will be squared. In the next step, we'll go ahead and we'll start the foiling process. We'll FOIL the numerator, but also in terms of what the denominator entails, that can also be squared as we'll separate it from the foiling of 1 plus cosine 2x times 1 plus cosine 2x. And I know I can do this if I were to just FOIL the numerator by itself. Obviously that's what we see, but the denominator of that squared is a fourth. So I could theoretically write this this product of two binomials over 4, but I'm going to instead factor out that 1/4 now. When I do go ahead and FOIL in the next step, I'll get first, so 1 times 1, outside 1 times cosine 2x, so cosine 2x plus another cosine 2x, so I have 2 cosine 2x, and then cosine 2x times cosine 2x, which is cosine squared 2x. Now, interestingly, what's about to happen here is I'm going to incorporate another of the applications of the previous formula, the power reducing formula from up above, cosine squared equals 1 plus cosine 2u over 2, but in a way in which, because it's not technically just x, it's 2x, we'll have to be careful. The angle itself, instead of, I'll write 2u, the angle itself is 2x, so 2 times, I'll make a note here, 2 times 2x, or 4x, is essentially the angle we're going to interpret them. So when we do the math in the next step, it becomes the following. It becomes 1/4 times the quantity 1 plus 2 cosine 2x, and then this quantity becomes 1 plus cosine, and again, instead of us using 2u, we're using 2 times that u, in this case 2 times 2x, so 4x, and that's all over 2. If the angle had, instead of been 2x, if it had been x, then yes, we would have used 2x. So really, if you think about it, we're just multiplying what our typical double angle is here by 2. So it became 4x. So we'll continue in the next step. We'll have 1/4 times the quantity 1 plus, again, 2 cosine 2x. This particular quantity I can actually split up because it's a binomial divided by a monomial. I can do this, so it becomes 1/2 plus cosine 4x over 2. Now we do need to simplify a bit more, and it turns out that we can factor out after we combine some like terms, these two can be combined. 1 plus 1/2 is 3/2. So we'll be able to now factor out a 1/2. So it's 1/2 times 1/4, which becomes 1/8 in the next step. Factoring out a half out of 3/2, in other words, 3/2 times 2, that becomes 3. And that still then is plus, but this 2 cosine 2x divided by a half or times 2 is 4 cosine 2x. And lastly, cosine of 4x over 2, factor out the half, which is really why I did that in the first place. That becomes just this. So we will see, and I'll simplify it one more step, we will see most answer keys show it as this, 1/8 plus times, 3 plus 4 cosine 2x plus cosine 4x. And that's it. That's our final answer, simplified fully. And if you notice, all of the cosines in our final answer are reduced powers such that they're first powers. Next page, half-angle formulas. So half-angle formulas are interesting. As we've seen in the past, where we were solving half-angles, now we're going to interpret the sine of u over 2, the cosine of u over 2, and the tangent of u over 2 as different forms, particularly with a square root. And you can see there's cosine as well as a fraction. So for example, the sine of u over 2 is plus or minus the square root of 1 minus cosine u all over 2. Cosine of the half angle is plus, while tangent, there's two versions for that. Example 5. Find the exact value of the cosine of 165. So the first thing we'll do is look at 165 degrees and stress that it's, of course, in quadrant 2. And because it's in quadrant 2, we know that the cosine of this particular angle will be negative. And then we'll go ahead and say, well, 165 is not on the unit circle. However, if you set it equal to half of u or equal to u over 2, we could maybe calculate u as a more familiar angle. And yes, we can. If you multiply both sides by 2, you in fact get a unit circle angle of 330 degrees, which is quite nice. Now we can actually use the half angle formula with the cosine of 330 now over 2. 330 divided by 2, of course, is 165. And that will be equal to, if I look above here, plus or minus the square root of 1 plus cosine of 330 all over 2. Now, the plus or minus in front is important to note now, in that because we noted at the beginning that the quadrant 2 angle of 165 will be negative, that means that we're able to cross off the plus sign, and that the answer, of course, will be a negative root something, in which now let's simplify. Remembering our unit circle, we have the cosine of 330 degrees, thinking about a fourth quadrant angle. The x-coordinate of this particular angle is root 3 over 2. Again, remember from the unit circle. And I'll just simply rewrite everything as such. And we'll continue on here, in which we can really just simply get a common denominator with every single aspect here. If we look at it, multiplying this by 2 over 2, multiplying this by 2 over 2, this is going to allow us to then in the next step simplify very nicely. So negative square root, I'll have 2 halves plus root 3 over 2 all over 4 halves. And that's where in the next step you'll see the 2's, as we've seen in the past, divide out quite nicely. Let's combine though. So 2 plus root 3 over 2, and then 4 over 2. So yes, dividing by a fraction is the same as multiplying by the reciprocal, and those two will divide out very nicely in that regard. And then you can take the square root of the denominator, which leads to a very nice answer comparatively. And that negative square root 2 plus square root 3 all over 2. And yes, that nuance of that root in a root is a little bit interesting, but that is in fact the answer for this particular problem. We checked the answers in the past. So I'll do that quickly here. We'll do the cosine of 165. Make sure your calculator is in degree mode. And we can go ahead and see, after typing in the cosine of 165, and then typing in negative square root 2 plus square root 3. I'll hit enter on that, and then divide that by 2. So that should in fact be the same thing. The cosine of 165 is this decimal, negative 0.9659, which we also proved using the exact value answer we came up with. Let's move on to example 6. Solve 2 sine squared of x over 2 equals cosine of x on the interval 0 to 2 pi. So what I'll go ahead and do in my first step is right here just simply divide by 2. And that's going to quite nicely lead to the following. I'll have sine squared of x over 2 equals 1/2 cosine of x. Because I do want to get this down to either sine or cosine, I'm going to go ahead and square root both sides. And in doing so, that leads to the sine of x over 2, and that equals plus or minus the square root of 1/2 cosine x. From here, I'm going to incorporate a half angle formula. The half angle formula, if you recall from above, for sine of u over 2 is plus or minus square root 1 minus cosine x over 2, or u over 2. I'll use x here, of course. And that's still equal to the same thing, plus or minus square root 1/2 cosine of x. Now this is quite nice because actually when we have 2 square roots on either side, we can square both sides of the equation. And when you square both sides, that leads to 1 minus cosine x over 2. Notice the plus or minus disappears because when you square a plus or a minus, it becomes a positive. And then on the right side, 1/2 cosine of x. Still nice in that it's, as you can see, well, it's nothing but cosine. But the halves can actually be multiplied, both sides of which multiplied by 2. I'll show that. And so from here, we have a much simpler equation. 1 minus cosine equals cosine. And because we still want to get cosine and then x by itself, we can add cosine to both sides. And so that 1 equals 2 cosine of x, or if we divide by 2, cosine of x equals 1/2. Now we can algebraically justify that the 2 angles, and there will be 2, the 2 angles that have an x coordinate of 1/2 will be pi over 3 and 5 pi over 3. And those are my 2 answers algebraically. Graphically speaking, we can type this in, and it turns out with y1 set such that it's 2 sine squared x over 2, and y2 cosine of x, you'll see these 2 functions, and you'll see them intersect here and here. So pi over 3 and 5 pi over 3. The graphical solution I've already done for you, so we'll go ahead and take a look at the next page and continue here with product to sum formulas. Product to sum formulas are great because when you have the product of sine u times sine v, for example, so 2 different angles, that will be equal to the following: 1/2 cosine of u minus v minus cosine u plus v. Similarly with the cosine u times cosine v, here you go with the result: sine times cosine, cosine times sine. So rewrite sine 2x as a difference, sine 2x times sine of x as a difference. So this is, as it turns out, the sine of u times sine of v. So simply 1/2 from up above times the quantity, cosine of the angle subtracted, 2x minus x, minus the cosine of the angles added, so u plus v from above, so 2x plus x. And we simplify so that 1/2 cosine x minus cosine 3x, which in turn leads to 1/2 cosine x minus 1/2 cosine 3x. Sometimes the textbook will simplify as such, sometimes they'll leave it as the previous step. This concludes part 2. In class, we will finish the notes.